Hello everybody, thank you for checking out my video of most missed questions. Anytime you got a table, so what you should be doing, make sure you understand, and this is the phrase I actually used to use previously, but Y1 now I'm teaching Y1 is similar to, of course, a 1 plus the rate, which I was calling B, and you're welcome to put B for the x to the first power. That way, the rate will come out of here as like 0.03. But before it would come out like the rate, like this would come out as 1.03. You can do either way that you like. So that is again, when you're given a table and you want to put in Desmos, that's what you'll use. So newest thing we learned is compounding. Given like quarterly or daily, you need two n's in the formula. The basic exponential setup, starting point 1 plus or minus the rate and time. Then, of course, I've just figured out that we don't need this in Math 3, but compounding continuously is PERT, with the RT being exponents. You don't need to know that for my test. So let's go from daily to yearly would be 365 times. It takes 365 days. But a month going up to years, it would take 12 months. Quarterly going to yearly, it would take 4 quarters to go to yearly. But to go from yearly to quarterly, that's only 1/4. You're breaking that year up into quarters. And then go from years down to months, that would just be 1/12 of a year. So you're trying to turn a 5.9% gain for the year to a monthly rate. Remember, 5.9% is 1 plus 0.059 if I move the decimal twice. And I'm breaking that down into months. So remember, we already started with the 1 or the 100%. We're gaining, when I move the decimal twice, 0.47, which is pretty much a half, almost like 0.5. And if I broke 5.9% down into dividing it by 12 for 12 months, it would be right about there. So that is a good little approximation to just do this divided by 12, but it doesn't work perfectly. Compound interest is being calculated. The starting point is 5,000. The rate appears to be 0.05, but it's compounding quarterly, hence the 4. Remember, there's supposed to be a 4 here, so somebody must have already divided. It must have used to be 20, because 20 divided by 4 would leave us at 5. That one was a little tricky. Here, just be careful, don't use the money again. We're converting 75%, which is a 25% loss, by the way. We're adjusting this to the monthly, so I'm going to raise it to 1/12 again. Don't use the money. You're just breaking down the rate. And each month, basically the rate would be 0.97. It's showing about a 3% loss, or more like 2.4% loss each month. So I think to match us probably would have been a better, tougher, more challenging question had I put like the money and then 1 minus the 0.024. Because that sort of hides it. Remember, you need to be able to recognize that this is 97% we're keeping. We're losing about 3%, or 2.6% to be precise. Which of these functions is increasing for all intervals of this domain? So last unit in rationals we did 1 over x, but it's decreasing here and it's decreasing over here. The whole entire thing is decreasing. One of the other answer choices is your basic parabola, x squared, and it is decreasing on one side but increasing on the other. Well, in this unit, we talk about stuff like a number to the x power. And, well, you wouldn't want a base of 1 because that wouldn't change, but take 2. This function is increasing the entire time. Go as far back as you want to go, and it is increasing. So make sure you know how to type a table in and to get information out of the table. And I've since edited the question to what is the starting point because, well, I'll show you why. So here I got the table in by pressing the plus sign and choosing table. And I got my statement in that I was talking about earlier. The rate comes out as 1 right here, but remember it's really 1 plus 1, so the rate is really 2. We're increasing 100%. Notice it's doubling each time. This was a little tricky for this, which is why, again, I changed the problem to what is the starting point or what is the y-intercept. Remember, starting point and y-intercept the same. So you're going to see me enter 2, but again, I've changed the question. The exponential table represents the number of bacteria. When will the bacteria reach 20,000? So same table I was just dealing with. I put y equals 20,000. Remember, y is for the subject, x is always for Tom. So I need to scroll out until I can see 20,000, or I need to adjust my window. As a matter of fact, I know y'all know how to scroll out just to get you some extra practice with this. Remember, your x is your Tom, so maybe we want to see Tom from year 0 or minute 0, whatever the problem is talking about, for the first 10 or 20 minutes. That looks like a good view. For a while, we don't really see negative numbers for the subject, but maybe it goes up as high as 25. Well, it'll go up forever, technically. So remember, if I'm trying to look for a certain number, I'm trying to see when it reaches 20,000. So I definitely want to go up higher than this. I changed it to 25,000 for my window. We'll hit 20,000 after 12 years or whatever the problem is talking about. Oh, there was another 12 on there. 12.3 was on there. Moving a little too fast. Now, we already know the y-intercept of this was 4. That's from a couple problems ago. The graph is different. The graph has a y-intercept of -1. How far apart are the two y-intercepts? So one is up here at 4, as you saw earlier. The other one's down there at -1. How far apart are they? They are 5 units apart. Now you can Desmos this and see where they cross each other, put y equals this side and put y equals the 200. I'm going to do it by converting to log. So we're in exponential. I need to convert to log. The base is 4. The exponent is -2x plus 5. That is an exponent. The number here is 200, number on the other side. We get rid of plus 5 with -5. And we get rid of times -2. That's a -2 times x. We get rid of that by dividing by -2. I type all that in, and it's going to give me the same answer as wherever these two lines will intersect each other. Took a little bit, but I typed it in, got 0.589. Convert to exponential form. So be careful, you're still asking yourself, and there's a good trick on this one. You're asking yourself about BEN. What's the base? The base is 2x. What's the exponent? A log statement always equals the exponent, but you need to raise the whole base to the 3rd power, so you absolutely have to parentheses that. The number on the other side is 50. And we could solve that, but again, it just asks us to convert it. Here you got a long cross and a long bounce. So these last two are review questions, by the way. Remember, a long cross counts as 3. Long bounce, definitely a long bounce the way it sits there for a while counts as 4. For a total degree of at least 7, now I'm saying at least 7 because remember, sometimes there can be imaginaries. We're not tasked with worrying about that right now. We're simply just adding up the multiplicities. And remember, it had to be odd because one end is going down, one end is going up. So it had to be 1, 3, 5, 7, 9, etc. So let that definitely be a clue for you. Remember the setup back in Unit 2, it's always x minus the perfect number or the goal. And for acceptable numbers, you always got to be off by less than or equal to the flexible amount. So the average January temperature in Toronto is 1 degree. That would be the perfect amount. And the usual January temperature is within 5. That's the flexible number. And it's a normal day if we're off by less than or equal to 5. If it's off by 4 degrees or 2 degrees, that's a pretty normal day, pretty usual day. If we're off by more than 5 degrees, that would be unusual or unacceptable. So T for temperature is good as well. And finally, remainder theorem, remember you're simply plugging in the opposites. You can do synthetic division if you want to. Make sure you understand this one will need a 0 in it. The opposite of x minus 2 would be 2. So we're going to do 2 times 2 to the third power minus 5 times 2 minus 7. Exponent comes before multiply. You're probably best off typing this in if you're not too good with being consistent with your numbers. But 2 to the third power is 2 times 2 times 2, which is 8. Times 2 is 16. There's a minus 10 right here and a minus 7. 16 minus 10 is 6, and 6 minus 7 is negative 1. Sounds like a good remainder, though none of the other ones necessarily sound like bad remainders. So remember, these were the tougher questions. If you're understanding these pretty good, no reason why you shouldn't get a great grade. Good luck tomorrow.